looking at rules of logarithms, like we learned about the rules of exponents. And before that, let's remind ourselves, is if y is equal to a raised to x, then log of y to the base a is x. This is the meaning of logarithms. It gives you the power or the exponent as the answer. So it tells you a raised to what is y. An example, log of 15 to the base 2 means 2 raised to what will give me 15 as the answer. So that's the value what logarithms will give you. Let's look at the rules in comparison with the rules that we know, which is rules of exponents. The first rule says a raised to x times a raised to y. If the base is same and the indices are getting multiplied, then we add the indices. Correct? In logarithm, it's right the opposite. So addition of two logs would be same as multiplication of the same. Or the other way around, I can look at multiplication as, let's take an example the way we used to do for exponents also. So log of 4 to the base 2 plus log of 8 to the base 2. We know log of 4 to the base 2 is 2 because 2 raised to 2 is 4. Log of 8 to the base 2 is 3 because 2 raised to 3 is, and therefore the answer is 5. Correct? Now according to the rule, addition becomes multiplication. So this should be equivalent to saying log of 32, 4 times 8 to the base 2. And 2 raised to what is 32? It is 5. So right hand side and left hand side are the same. So the rule is log x to the base a plus log y to the base a. Again, remember the base has to be the same, otherwise the rule will not work. Same like the exponent. Addition will become multiplication, or you can say the other way around also. Multiplication becomes addition. Log of xy to the base a is log of x to the base a plus log of y to the base a. Okay, let's look at our next rule. A raised to x upon a raised to y. When base is same, then and we have a division, then the indices get subtracted. Okay, the other way around. Log of x to the base a minus log of y to the base a. Subtraction is written or can be written as division. Let's take an example again. So log of 9 to the base 2 minus log of 9 to the base 3 minus log of 27 to the base 3. So I'm looking at numbers that we are familiar with. We know 3 square is 9, so log of 9 to the base 3 is 2. 3 cube is 27, so log of 27 to the base 3 is 3, and 2 minus 3 is minus 1. So my left hand side answer is minus 1. Now let me look at the right hand side. Log of 9 divided by 27 to the base 3. The base has to be the same. And log of 9 divided by 27 is 1/3. And the answer 3 raised to what is 1/3? It is minus 1. So the right hand side is equal to the left hand side, and therefore our rule is correct. The next rule was a raised to x raised to y. Whenever there were an index raised to another index, then indices would get multiplied. Now what happens to the rule in case of logarithms? Correct? Log of x to the base a raised to m. When there is an index, the index becomes a power. So this is slightly different. It may seem slightly different, right? That index becomes a multiplication. But even here, if you see, index is getting multiplied. So even here the rule is index is getting multiplied. So the power is coming, is being taken outside and is becoming like a multiple. And let's take an example for us to remember this well. So log of 4 square to the base 2. So the rule says it should become 2 times log of 4 to the base 2, right? The power should come out. So let's look at it. Log of 4 square. What is 4 square? 16. So log of 16 to the base 2 is 4. 2 times log of 4 to the base 2 is 2. So 4. So LHS or left hand side is equal to right hand side. So the rule is correct. The next rule, log of we start with exponents, right? So a raised to 0 is 1. Anything raised to 0 is 1. Correct? In log we get the power. That means log of 1 to any base must be 0. It's just the opposite operation. So log of 1 is going to be 0 and the base can be anything. So log of 1 to the base 10, log of 1 to the base 100, log of 1 to the base 2 is 0 because anything raised to 0 is 1. Correct? There's one more thing then. A raised to x, can this ever be a negative number? So think properly and tell me. For example, let me take a raised to x, a as 2, right? 2 raised to x has to be minus half, not plus half. Can it ever be? Well, 2 raised to 0 is 1, 2 raised to minus 1 is half, 2 raised to, even if I raise to minus 100, it is 1 upon 2 raised to 100. It's becoming a very small number, but it is not even becoming 0 ever. Forget going to negative value. So that means all exponents are essentially staying only in the positive region. This is interesting to note, right? 2 raised to minus 2, 2 raised to minus 1, 2 raised to 0, and 2 raised to 1. So it's starting from very small values. If I go from left hand side, it's a negative number towards the positive value, I'm seeing that the exponent value starts from very small value and goes on increasing in this case, but it is never actually reaching 0, so not even reaching negative. That means the reverse. Log of x to the base a, x cannot be negative ever. Can x be even 0? No, because exponent never even reaches to the value of 0. So I cannot give 0 or negative input. It cannot be less than 0 because it is just the reverse operation of exponent. So again, let me summarize the rules and that's where we'll go from. So log of x to the base a plus log of y to the base a is log of xy to the base a. Addition is becoming multiplication. Log of x to the base a minus log of y to the base a is log of x by y to the base a. Log of x raised to m to the base a is m times log of x to the base a. Log of 1 to any base is 0. I cannot have negative input or 0 input given to a log function because you know that exponents are never reaching 0 or negative number. There is a change of base rule, but we will see that in the next video.